Next, let's talk about throughput and latency. Throughput and latency are two concepts that are really important, not just for the exam, but also for data engineering in general and cloud computing in general. They are, as we will see, they are related, but they're not the same. We can think of throughputs like traffic on a highway. So throughput is like the number of cars that can pass through the highway per second. The more lanes a highway has, the more cars can move through at once. Just like a system with high throughput can process more data simultaneously. So throughput is all about how much data a system can process per unit time. Gigabytes per second or records per second are the typical metrics that we use to describe throughput. And when a system has high throughput, it means it can handle and process a large amount of data efficiently. So take a pipeline that can ingest 2 gigabytes of data per second, for example. This would generally be considered high throughput. 2 gigabytes per second is a pretty large amount of data per second, and so that's a significant volume without slowing down. Now let's talk about latency. Using the highway analogy again, if you're moving smoothly and then you take your exit only to hit a traffic light or intersection right after the exit, that brief delay at the intersection represents latency. In data terms, latency is the delay between when data is ingested and when it becomes available for further processing or querying. Low latency means that this delay is minimal, allowing for quick access, often in real time or near real time. And so, for example, in a low latency system, data can be ingested and become queryable within a few milliseconds. It's a pretty good standard. Now, when comparing them, it's important to remember that they aren't the same thing. High throughput does not always mean low latency. So here's an example of high throughput and high latency. A system designed to process large amounts of data, meaning high throughput, could still take time to make that data available for use, leading to higher latency. On the other hand, low latency refers to data being available quickly after it's ingested, but that doesn't guarantee the system can handle large volumes of data all at once. This would be considered low throughput and also low latency. So high throughput does not always mean low latency. Let's look at our analogy of traffic again. So if there's a delay at a traffic light, which would represent high latency, a highway with many lanes can still allow many cars to pass through over time, representing high throughput. In contrast, a system with low latency may allow fewer cars to pass at a time. So even though each car passes quickly, the total number of cars processed over time is lower, meaning low throughput. So check out this image. This is a real world example. It shows a highway in China with over 40 toll booths. There's a significant delay for each car to pass through, so the latency is high. But because the large number of toll booths exists, a massive number of cars can be processed overall, demonstrating high throughput. So you won't always have to, parse this difference, but it is important to understand sometimes something will have high throughput, but it won't have low latency, and vice versa. So 2 important concepts for the exam, throughput and latency. I hope that helped you grasp them.